All right. Is your entire IT staff outsourced 20 somethings? Is your cloud environment architected by a thought leader's fever dream? Have you swallowed heaping gallons of the DevOps Kool-Aid only to find out that you're one misconfig away from losing everything? Ochaun Marshall here to invite you to flex seal your CI/CD pipeline. If you're interested in diving deeper into this topic, my slide deck is hosted at this link right here, TinySI, FlexSeal. I promise it's just a slide deck, PowerPoint. Also, feel free to ask questions during the talk. I've got a corner of somewhere in this range is my phone, and I'm looking at the Twitch chat to see if I can respond to the questions. So, without further ado, let's get started. Brief introduction to about me. I hate about me slides, but my boss tells me this is necessary. I'm a software developer / security consultant for Secure Ideas. I code, I teach, I hack, meaning that when I'm talking about application security, it's not just I'm not separated by layers of abstraction. This is stuff that I have to work on implementing by hand to make functioning software work. I also teach. I write code. I also blog, and I also teach live demos and instructions like this often. And I also hack. I work for Secure Ideas. We are a red team penetration testing, do mostly specking into web app security. So for a living, I break web apps and on purpose, and then I break web apps accidentally when I actually code and develop. So a full profile, that's the simple rundown. A full profile is available in a link in the slide presentation notes. So here's the ground that we're going to cover. First, I'll discuss what a CI/CD pipeline is, and then we'll focus on 3 strategies for funneling security throughout the process. All of these strategies are inspired by FlexSeal family of products. If you have no idea what I'm talking about, just Google FlexSeal. You're bound to have a good time with this. But first, we'll just talk about, in general terms, about IAM after the definition. Then we'll go into gluing things together with CloudFormation, then FlexTaping together packages together. And then we will go into flex sealing our containers that we use in our CI/CD pipeline. Then I'll close with the demo and a few closing thoughts. So we're all on the same page here. A CI/CD pipeline is a system that allows multiple versions of source code to be integrated, built, and ready for deployment. In the perfect world, we get from code in a Git repository into production in seconds. In the real world, we could either end up something that is painfully slow, or something where we've got credentials and things leaking everywhere. So the focus of this talk is about baking as much security as we can in the building, testing, and development phases of the pipeline. There are a lot of tools available in this space. Great players like Travis, GitLab, Jenkins, all of these other players, but I'm going to be focusing on AWS Code Pipeline. Why do I'm focusing on this? Because it's the tool I'm most familiar with, therefore it is perfect. No, it's a decent tool and it's relatively easy to set up. So Code Pipeline is a service that allows you to automate build and deployment processes. They can be as simple as a 2-step deployment to get from a public site to an S3 bucket, or as convoluted as you would like. When you use Code Pipeline, you get temporary access to a build container with the AWS CLI installed, Bash, and outgoing internet access. The other tools we'll discuss will fit neatly in this, but first we need an example. Now imagine for a second, you're building an online portal, but you decide it's going to be serverless. So you'll deploy the client-side application to the S3 bucket. All the requests will be handled by Lambda functions defined in an API gateway and a REST API defined in an API gateway. And user information and user groups can be stored in DynamoDB. Each of those lambdas will need to access different APIs at different levels of authorization, depending on the permissions and the roles of the user. Now, does that sound convoluted? You have no idea. But these are the types of applications people are building nowadays. When you're saying that we're going serverless and things like that, um, all of these cloud native applications will be dozens of services communicating and speaking with one another. So the question is how do we tie this stuff together? We could very well have engineers creating things like this in the console manually, but that process to me sounds like trial and error waiting to happen. So we need something a bit more streamlined, a bit more automated. But first we need to go over some basics, like what is IAM in AWS? So IAM stands for Identity and Access Management, and that has to do with users and entities acting on users' behalf. So let's go over this in a quick overview. So users and groups, pretty straightforward, right? User or just group, you can assign roles and permissions and rules and policies to a single user or a bunch of users in groups. What a role IAM role is a role is just a group of policies. And what a policy is a single JSON document that specifies what a user can and cannot access. So let's start with an example. I'm a user in my company's AWS environment, and I have two roles. One is a role as a developer, so I access to some source code that's stored in AWS Code Commit and some playbooks that we often do in pen tests. As a consultant and as a red teamer, I also have the consultant's role, and I also have permission to spin up infrastructure for engagements, like creating an EC2 instance for cracking passwords. So different roles have different policies embedded in them that will control what people can and can't access in AWS. Now, I also want to cover another example that you will encounter often when you're actually building working applications in AWS, and that is AWS resources, because AWS resources all function in this IAM system. So resources like the code pipeline have their own built-in service role in which you can add policies to them to open up services and things like that, or the pipeline. So in the example that we discussed before, where we're trying to build our serverless portal, we need to make sure that the code build project within the AWS pipeline also has a policy that has access to spin up the infrastructure that's needed to CloudFormation, that has access to GitHub bucket where the code is stored remote, and it also needs access to the S3 bucket to deploy that client-side code. Now, that process can be federated through S3 bucket policies, but since I've got 30 minutes with you all, it's way out of scope for this talk. So we can mess up, and as we've learned since like 2016, 2017, you can mess up your S3 bucket policies and open things up to the wide open internet. But messing up in IAM policies is a bit more subtle. So when you mess up your IAM policies, you give certain access to entity, you get certain entities or certain users way too much access that they needed. And we'll cover this with an example. So for example, Capital One, in the Capital One breach, we've got a public facing web application that was compromised, all right? Once that web application was compromised, the attacker was able to get on the EC2 instance in which that web application was running, right? So once the attacker got there, she said, "Oh, well, let's see what kind of with one line, a quick query to see. Let's see what's access for this EC2 instance has. Oh, it has full S3 access. Well, why don't I dump all 300 buckets and see what's in there?" So when you're deploying things on service infrastructure, on even if it's not whether it's serverless or not serverless infrastructure, when you're deploying some things in AWS, you need to keep in mind what access you have to what infrastructure has what access to what. You have to delegate access to this old-fashioned principle of least privilege. Now, if that EC2 instance instead had access to a specific bucket to only get a certain files within that specific bucket, the breach wouldn't nearly be as destructive as it would have been. So secure use of AWS involves mastering IAM roles and IAM policies. Now, we're going into gluing things together. And I hate to break it to you, but most of what we think of as code, most of what I think as my own code, isn't really my code. I'm really relying on microservices, libraries, open source, and legacy code. And cloud native applications are the exact same thing. So when we think, we think that we're just creating these harbingers of the modern era, we're actually gluing together AWS multiple cloud services. So this is where a CloudFormation template comes in. So a CloudFormation template is a blueprint for provisioning cloud services. Think of it as a UML diagram, except this actually creates working software. Plus, you can push a button and you can deploy the entire tech stack for an application in a single JSON file. So you can provision most AWS services, including the IAM roles and policies that we talked about earlier in CloudFormation templates. This is an awesome and powerful tool. So rather than having your security team trying to go into your cloud environment and poke and prod at each of these services to figure out, okay, what connects to what, or trying to do this via tagging system, you can actually have the infrastructure and the identity and access management built in and written into the code for the web application. This also means that you can version control it. You can know you can point to a line in the source code that can be fixed, And you also have the ability to replicate and spin it up in test environments. So if you're going to be gluing things together, let's flex glue it together and get something that looks a lot better. Now we jump over to FlexTang. So this is a bit of homework for anyone who has Node in their stack. You can use the package manager to audit all of your dependencies for vulnerabilities. You can use this npm audit, simple, and it could give you either a laundry list of vulnerabilities or nothing, So often you'll find that the test won't produce much, or be low or informational findings. And sometimes when you're looking through code, you will find a whole lot of stuff. So this is a simple way to address the problem of the software supply chain in the pipeline itself, if you're using JavaScript and if you're using Node. And you may think, okay, well, there has to be an immediate, you can ring up all these errors, but how can we patch it and how can we fix it? A lot of these fixes can be applied with just adding another argument, npm audit fix. Now, this won't cure everything. Sometimes there'll be baking changes and you'll have to adjust the code a bit. But right there, you have a simple, easy tool that you can implement right now if you're running a Node.js application, and get a list of what's wrong, where dependencies are wrong, what adjustments that we need to be made, what dependencies that we need to migrate away from or have to implement our own manual fixes for. Now, not every patch will be easy, but a lot of them, when I say a lot of them are just this simple. And there's similar tooling in C#, Java, Go, and many other languages. And a lot of that tooling can be open source. So if we're going to, don't just fix your dependencies, seal them up with FlexTang. Now we go on to container security. There is no way I'm going to cover everything with container security right away. But here are some quick and dirty tips that we can do, we can implement immediately. So with Code Pipeline, AWS gives you a provisioned container with basic deployment tools. But the beautiful thing about it is that you can specify your own containers as well. Now, some of you are using Docker or multiple containers in Kubernetes cluster. These are tips that help basic 101 security hygiene sort of things. One, don't run more services that are needed. You have to realize that the container is not a VM. You don't have to load it up with everything in the kitchen sink, including those high-level orchestration tools. If you're having a cluster, you don't need, like, every node in the cluster doesn't need access to the Kubernetes dashboard, for example. And there are a lot of times if I'm on an engagement and I pop a container, one of the easiest ways to make it harder for me to privilege escalate, to try to deploy malicious containers in a Kubernetes cluster is just getting rid of basic tooling that the container doesn't even need. So if you remove curl, if the container doesn't need access to curl, but you remove it, that makes it so much harder for me as an attacker to be able to get tooling from the internet. And most automated scripts will just be running things like that. Second thing you need to understand is that Docker access is root access. So the Docker daemon runs as root. So if you add a user to that Docker group and give them access and allow them to spin up and use Docker, guess what? With a few commands, they can easily do a quick privilege escalation to root. Now there is rootless Docker that's available, and I link to it into the slide deck, but that is experimental. You're free to open to it. Try to get that to work. But as it currently stands, like prod level Docker, if you give user access to Docker, you're giving them root access. Also, you need to make sure to avoid adding Docker by doing bind mounts. The problem with bind mounts is that they open up the entire file system of the host to the container. Most of the time, you're just talking about opening up one or two directories to a container to read and access files. That can be done with just a volume mount, which is a TAC v argument. And then 4, you need to understand that just because a container is kind of a misnomer, you don't have that same level of abstraction and same level of separation as a VM. It's not actually a security. It's not actually a security thing. It's not actually a security control. Containerizing things won't change the security of your application at all. So if you want to improve the security of your containers, you also have to make sure that you do your due diligence and maintain the host and keeping the host level kernel patch, because the host shares kernel with the containers as well. So those are some 4 quick and dirty tips. And now we go to the demo. So we put here in this demo, we're going to be putting all of it together. Now, this is a brief demo of the hypothetical serverless application that we discussed earlier in the talk. And when we dive into the logs, we notice, oh, the build execution failed. So let's dive in, let's go into the logs and investigation. Now we see that the CloudFormation templates worked well. We see that the services, IAM rules and services were done correctly. There are some bugs, but there's some client-side building bugs, but those don't seem to be a problem. What seems to be a problem is this cross-site scripting vulnerability. Now, I don't know about you, but my boss will not let me release code with cross-site scripting on it, with cross-site scripting vulnerabilities on it. Now, if you're in a let's say high availability environment in which you have different levels of requirements, and you don't want to shut down the whole pipeline, that's fine. But you can, since you're auditing things and it's just JSON and it's in the pipeline, have an alerting system either in CloudTrail or CloudWatch to just ping developers, ping operators, ping whoever is needed to apply these patches. And so that someone can run the npm fix, if not have it automated and run the npm fix in the pipeline itself. So whatever you do in your environment depends on your tolerance for risks and your processes for vulnerability management. But a lot of this information you can ping it off and build off of while you're doing the work of building your application anyway. Now, this saves a lot of time, a lot of effort, and a lot of money. Because imagine paying a few couple of $1,000s, getting a pen test, and then having pointing the security teams, or having the security team point Nessus at it, going through all of those hoops. A lot of these problems can be addressed or can be discovered by simply doing the diligence while you're doing the heavy lifting of building the application anyway. And then, so you may ask, well, where's the tool that automates all this work? Well, I'm sorry, I don't have it. I've shown you tools, tactics, and strategies to help builders and security teams be more effective. There is no, although these are helpful, these are not any of these strategies aren't a handyman in a can. None of these tools replaces the people that must use them. So whether you're a builder or an InfoSec, you're a plumber. You're either laying down pipes, checking for leaks, or fixing them. And by strengthening the connection between parts, by analyzing your building materials and preventing data leaks, you can keep the flow of information going for your organization. And that's it. I'm pulling up phone locked up again, so I'm looking at Twitter, at Twitch for any questions if anybody has. But yeah, hit me up on Twitter, LinkedIn, send me an email. The slide deck, everyone at all the links to everything that I was talking about is available in the slide deck. And also in Twitch chat, feel free to talk to me. Say, oh, well, you missed about this part and whatever. That's fine. If I'm wrong, I'm wrong. But yeah, thank you for your time. Thank you for your attention.